we are going to calculate the net force with the help of the free body diagram. Okay, we are discussing how to draw the free body diagram. Already in the previous video we have discussed there are some rules to draw the free body diagram. What is that? First decide the system, then list out the forces acting on it, then finally draw the free body diagram of this. Okay, so now one example I going to explain here. Draw the free body diagram of a ball rolling across the floor. Okay, so what is our system now? Ball is our system. Okay, so ball is our system. Now we have to list out the forces acting on it. Just imagine this is the floor, this is the ball. Is this ball at rest? Is this ball at rest? Okay, so see here two things we will discuss. Draw the free body diagram of a ball rolling across the floor. That is different. Okay, draw the free body diagram of a ball at rest. First we will discuss at rest on the floor. If we discuss this first, then you will understand rolling across the floor easily. Now ball is at rest on the table. Okay, so generally it seems there are no forces are acting, but in reality already we have discussed in the previous there are two forces are acting. Tell me what are those forces? Guess and tell me. One is gravitational force. Good. The other one is this ball in contact with the surface, right? This surface exerts a normal force on the ball in opposite direction, which is equal in magnitude of the gravitational force. Okay, so now we have to list out the forces. Tell me what are the forces acting on this gravitational force downward direction. Okay, this ball is in contact with the floor. This floor also exerts a normal force on the ball opposite to the gravitational force and balancing. So normal force. Gravitational force denoted by W is equal to mg. Normal force denoted by N. Okay, so now these are the forces acting on the ball which is at rest. Now we have to draw the free body diagram. See, this is the ball. Okay, gravitational force is acting towards down. One force is acting gravitational force towards down. Okay, the other force acting normal force towards up. Gravitational force is due to earth. Normal force also due to floor. This floor exerts normal force because there is a contact between the ball and the floor. Now net force we are going to calculate. Net force is equal to algebraic sum of all the forces. That means gravitational force plus normal force, algebraic sum. But as these forces are acting in opposite direction, we have to consider negative. One of the forces taken as negative. So then W minus N. We know that two forces are equal in magnitude. That is why net force acting on this ball is 0 because it is at rest. That is why it is at rest. Now same ball, another example. Okay, this is one of the example. The other example, same ball rolling across the floor. Same ball rolling across the floor. Rolling across the floor. That means this ball is going this way, rolling across the floor. Whenever a ball is rolling across the floor, what is the reason? Because we kicked the ball, we pushed the ball, right? Then this ball is rolling across the floor. Does the ball move continuously? No. It comes to rest. It slows down. Why a ball which is moving on one of the surface? See, a ball which is moving on one of the surface, why it slow down? Why does it slow down? What is the reason? Yesterday we have discussed in types of forces. Tell me what is that? See, another example also I will give you. For example, you are riding bicycle. If you stop applying force on the pedals, your bicycle slows down. When you stop accelerating while you are driving scooty, it slows down. Why all these things are happening? What is the reason? Because friction. Yes. Here another force is come into play. So previously there are two forces are acting on the ball which is at rest. Even though ball is now it is rolling, that two forces are common. Gravitational force acting downward direction, normal force acting upward direction due to the contact of this ball and the floor. But when this is rolling across the floor, another force is coming to play. What is that? Frictional force that is acting opposite direction of the motion. This is the direction of the motion of the ball. So we refer what the direction of the motion of the ball. When ball is rolling across the floor towards the right side, the frictional force on the ball acts towards left side. Okay. So total how many forces are acting on the ball when it is rolling across the floor now? 3 forces are acting. Tell me what are they? Okay, now ball is our system. Okay, one is gravitational force, the other one is normal force, and the third force is frictional force. Now we have to draw the free body diagram for this. Okay, so this is the ball. Okay, the ball is going towards the right side. So it gives the direction of motion. Direction of motion of the ball is towards right side. Okay, this is. Now gravitational force acts downward, normal force acts upward, and this normal force and gravitational force both are balanced. Vertically forces are balanced. Vertically net force is 0. Okay, so net force along the x-axis or y-axis. Y-axis is vertical, right? When you take the graph like this is x minus x, y minus y, right? So this is vertical, this is horizontal, right? Vertically we are talking about. Here vertically 2 forces are balanced. So net force along the y-axis is 0 because net force is equal to W plus minus N. Both are same since gravitational force equal to normal force. That force acting on it 0 in vertical direction. But horizontal direction, if you take net force along the x-axis, in horizontal direction how many forces are acting on this ball? There is only one force acting on the ball while it is rolling across the floor. Due to this force, that ball slows down. Okay, this is negative force acting on the ball. Actually this is the direction of the motion, but the force act on the ball in opposite. So F net along the direction of the x-axis horizontally, that is equal to only one force. That is what? Frictional force. So frictional force generally denoted by small m. So here what is the other force acting on this body? Frictional force. You see the direction of the frictional force, this is opposite to the direction of motion, isn't it? Okay, I hope you understand how to draw the free body diagram. Okay, previously we have discussed when ball is at rest only there are 2 forces acting vertically, but as the ball is rolling across the floor, another force is coming to play, that is frictional force, negative force, which slows down the ball, and that force also we have to show in the free body diagram. The force direction of this friction is opposite to the direction of the ball. Okay, along the vertical direction net force is 0, but along the horizontal direction force is acting opposite to the direction of the force. There is only one force acting, that is frictional force. Frictional force denoted by F. Okay, so some other examples also we will discuss. So before going to discuss examples, please note down this example and net force. Draw the FBD free body diagram. Let us discuss another example. A book is sliding on a table. Let's imagine this is a book table. On this table, this book is placed. Okay, we exerted some force and released our hand. Then this book sliding from one of the side to the opposite side. Okay, now this book is reached here and finally come to rest. Okay, now we have to draw the free body diagram during this case. While it is sliding, we have to draw the free body diagram. Okay, so tell me generally how many forces generally act when book is at the rest on the table? Gravitational force, normal force. Okay, when it is sliding, it slows down due to frictional force. So another force also come into play. Okay, so total how many forces are acting on this book? 3 forces. First decide the system. We have decided book is our system. List out the forces acting on it. Okay, so book is our system. Now focus on the book. How many forces are acting while it is sliding? One is gravitational force downward direction. Okay. Normal force in upward direction. As this book is sliding towards right side, there is a frictional force acting on this book surface between the table and the book, that is opposite to the direction of the motion, that is F, small f. So friction. So total how many forces are acting? 3 forces are acting. Now we have to draw the free body diagram. See, gravitational force on this book is downward direction. Normal force by the table on the book is upward direction. Vertically these two forces are balanced, so there is no net force along the vertical direction. Along the horizontal direction, net force is equal to only frictional force, because this frictional force is not balanced by any opposite force or any other force. Here downward force is balanced by the upward force, or upward force is balanced by the downward force. These two forces are acting in opposite direction. That is why net force along the vertical direction is 0. But here this force acting horizontally towards left side, is any force balancing this force towards right side? No. The net force equal to only this frictional force. Now when book is sliding on the table, what is the net force acting on the book? Friction. Due to that net force, this book slows down. Okay? Right. So along the x-axis, net force equal to only frictional force. But along the y-axis, net force equal to gravitational force minus normal force. Okay? But it is 0 because both are equal in magnitude. The magnitude of the gravitational force, normal force equal. That is why vertically net force 0, but horizontally there is a net force. But that net force is a negative force which opposes the motion of the book. That is why it slows down. Okay, so note down this example. Another example we are going to talk about, that is, you see, an egg is falling freely from a nest on the tree. Okay, so let us understand this. This is floor, here ground, here we have the tree, right? Branches. Let's say, imagine there is a nest. Okay, but this egg from the nest, it is slipped and falling freely. Okay, falling freely on the ground. So during this case, we have to draw the free body diagram. Okay, I hope you understand. Right, just imagine here 2 cases are there. Okay, considering force of resistance of air, this is case 1. Case 2, neglecting resistance of air. Okay, so generally what happens when you ride the bicycle? Whenever some wind blow opposite to you, your cycle slows down, right? Because this air exerts some force on you, right? See, whenever you release one paper from the 4th floor, does the paper reach the ground continuously like these markers and pens? Do they reach continuously? Though no, the paper just move left and right like this and finally come to rest. Yes or no? What is the reason? Because air exerts some force on the surface of the paper. That is called friction. The force exerted by the air and liquid, okay, it is called a drag, because air and liquid are called fluids. The frictional force exerted by the fluids is called a drag, or it is also called fluid friction. So due to the fluid friction, but can we expect that much fluid friction which exerted on the paper or quill? Can we expect the same frictional force by the air on this egg? No, but exert some amount of frictional force present on the egg. When egg is falling freely, if we consider the resistance of the air, okay, we have to draw the free body diagram in this case. When egg is falling freely, there is only one force acting on it, that is gravitational force, downward direction. Now I am drawing free body diagram. W is equal to mg. Only one force acting downward direction. Okay, but if we consider the resistance of the air also exerts some force on the egg in opposite direction of the motion. So this is the direction of the motion of the egg, accelerating down. But a small force of the friction of air exerted on the ball, on the egg, in opposite direction of the gravitational force, but it doesn't affect that. Okay, what is the net force now? Net force is equal to larger force minus smaller force. gravitational force minus frictional force of the air. That is why the egg, okay, this egg falling freely. Okay, we are neglecting the resistance of the air. If we imagine there is no frictional force of the air, then how will be the free body diagram? There is only one force acting on the egg, that is gravitational force, downward direction. So this is the free body diagram of the egg falling freely if we don't consider the resistance of the air, if we don't consider the frictional force of the air. This is the free body diagram when egg falling freely if you consider resistance of the air. Okay, I hope you understand. Please note down this example. Let us understand another example. Okay, see, this is the car. The car is moving towards left. Okay, towards left, right? This car is moving with uniform motion, right? Now how many forces are acting on the car? We have to understand. So now we have to draw the free body diagram of the car. Okay, so draw the free body diagram of car. So as per our rules, what is our system? Car is our system. So we have decided car is our system, and we have to focus on the car. How many forces are acting? See, as these tires are in contact with the surface, here normal force by the road on the tire in upward direction, let's say that is N1. Okay, I will show all the forces. The normal force by the road on the tire in upward direction. Here also this tire also in contact with the road. So this tire also experienced normal force by the road on the tire in upward direction. There are two normal forces, N1 and N2, right? Okay. So this car is moving towards, okay, and gravitational force, another force acting, gravitational force. So here two normal forces are acting in upward direction, gravitational force acting in downward direction. First we are going to write the net force along the y-axis. In vertical direction, first we will write the net force. Okay, so net force along the y-axis. Y-axis means vertically, vertical direction. This is. Tell me in vertically how many forces are acting? One is down, two forces are up. Okay, so what is the force acting towards down? Gravitational force. What are the forces acting towards up? These two normal forces. Okay, so this is a gravitational force which acts downward direction, and this is a normal force which acts upward direction, and this is another normal force which acts upward direction. Then how do you calculate the net force? Okay, net force in this case is equal to these two forces act in the same direction, right? Okay, that is why this is N1, sorry, this is N1 and this is N2. These two forces, this is N1 and this is N2, and this is gravitational force, right? These two forces are act in the same direction. We have to add those two forces, N1 plus N2 plus, because net force is the sum of all the forces. But here gravitational force is opposite to the normal forces, that is why we consider minus gravitational force. Then N1 plus N2 together one resultant of one force minus this normal force. Finally net force is 0 because these two forces are equal in magnitude with the gravitational force, because gravitational force and these normal forces are balanced. That is why net force are 0 along the y-axis. Okay, now we are going to draw the free body diagram. Okay, F net along the x-axis. X-axis in the sense what? Horizontally how many forces are acting. Okay, is this car is moving? Is it in motion? Is it at rest? It is motion. It is in motion. Car is in motion, right? So there is an engine force acting on the car in forward direction. The engine force, let's say capital F. Capital F is the force exerted by engine on the car which drives the car forward, that is F. Okay, what is the other force now act on the car? We know that when car is moving towards this direction, there is a friction between the tires of the road and the tires of the car and surface of the tire and road. Okay, what is the direction of the friction? Friction always act opposite to the direction of the motion because it always opposes the relative motion. So the direction of the friction is opposite, that is denoted by small f. Okay, now tell me, horizontally how many forces are acting? Two forces are acting. What are they? Engine force towards left side, that is capital F. Frictional force towards right side, that is small f. So the net force along the x-axis, engine force plus frictional force, but one of the force is taken negative because both forces are acting in opposite direction. Okay, here frictional force act towards left, engine force act towards left, frictional force act towards right. That is why we have to consider one force is negative. Okay, but generally which force is larger? Can we write F minus F or F minus F, small f? Okay, which force is larger? See, frictional force is greater usually. How? If the engine force stops, frictional force exits between the tires and road and this car slows down. Yes or no? When you accelerate more, the engine force increases. That engine force every time should overcome the frictional force. Then only it is move forward. If this engine force doesn't overcome the frictional force, it slows down. Okay, it is moving with uniform motion in the sense what? Engine force and the frictional force both are balancing. That is why that object is moving with the same speed without changing. Speed increases when this engine force becomes greater than the frictional force. Speed decreases when frictional force greater than engine force. But it is moving with what? Uniform speed. That means these two forces are balanced. Okay, so the force which is exerted by the engine on the car exactly equal to the friction between the tires and the road. That is why F minus F. Okay, F minus F. But since these two forces are equal in magnitude, the net force in this case is 0 because object is moving with uniform motion. Okay, I hope you understand. So please note down this. We have discussed this, right? Now same example, car is moving with non-uniform motion. Okay, here car is moving with non-uniform motion. Non-uniform motion means either car speed increases towards forward while it is moving towards that, car speed increases, either slows down. Okay, speed increase decrease. When speed breakers are there, speed decreases. When road is wide and empty, the vehicle driver increases the speed. Okay, but car is not moving with the same speed every time. Speed sometimes increasing, sometimes decreasing. Okay, sometimes increasing, sometimes decreasing. That is why we say non-uniform motion. Previously we draw the free body diagram for uniform motion. So this is a free body diagram for uniform motion of the car. When car is moving with the uniform motion, net force along the horizontal direction is 0, net force along the vertical direction also 0. So car is equilibrium state. But when car is not moving with uniform motion, moving with non-uniform motion, here these two forces are not balanced. Okay, compulsory the net force is equal to the difference of the two forces. Net force is something. If the frictional force is greater than the engine force, slows down. Okay, so vehicle slows down when frictional force becomes greater than engine force. In this case, what is the net force? In this case, net force is equal to frictional force minus engine force. Okay, so this is the situation. But when object is moving with non-uniform motion, only the net force is something along the x-axis, but net force along the y-axis remains the same. Okay, gravitational force act downward direction, two normal force act upward direction. These two normal forces are balanced by the gravitational force. That is why there is no change in the net force along the y-axis, but in horizontal direction along the x-axis there is a change in the net force if the object is moving with a non-uniform motion. Okay, so please note down this. Now we are going to talk about effects of net force. Okay, so generally when object is at rest, for example a ball is on the ground how many forces are acting on this? Gravitational force and normal force. As these two forces are balanced, the net force acting on the ball is 0. When net force is 0, or when object is moving with the uniform motion, okay, forces are balanced. At that point of time, net force is 0. But when object is moving with a non-uniform motion, net force is something. Okay, here that net force brings some changes in the object. What is that? See, generally net force change the state of the object. Change the state of object. State of motion of object. For example, you see here same ball. This is the same ball rolling across the floor. Okay. Here these two forces are common, but frictional force which is come into play. So this frictional force, okay, slow down that ball and ball come to rest. So here what is the net force? Frictional force is the net force. Net force can stop the object which is in motion. Whenever you play caroms, when you strike with the striker, sometimes your striker cannot reach the coin and hit. You disappoint, right? What do? Immediately you go and just bring the boric acid, okay, powder, then you will sprinkle that, then you play with the carom board. Then the striker goes smoothly and it hits the coins easily. Yes or no? What is the reason here? Previously, before we sprinkle the powder, what happened? There is a more friction between the striker and the surface of the caroms. That is why striker doesn't reach the coin. But after sprinkling the powder, friction reduced. Okay. So whenever one object is moving on other object, friction opposes. Here striker slows down before hitting the coin because of the friction. Friction opposes the motion of the striker. Understand? Here a net force can stop the object, and also it can set the motion in the stationary object. Stationary in the sense object which is at rest. For example, there is a table, okay, on the floor. There is a table on the floor. Now we want to move the table from one place to the other place. What do? We just apply some force, net force, then table is moving from one place to the other place. Previously, before we exert the force, the table is at rest, but the table is in motion. When there is a ball on the ground which is at rest, when we kick the ball, that ball undergo motion. Yes or no? Whenever bowler is bowling the ball, the batsman hitting the ball and the fielder catches the ball. So fielder stop the ball, batsman change the direction of the ball. So the bowler give the motion to the ball. Yes or no? So here bowler exerting force on the ball, batsman also exerting force on the ball with bat, and the fielder also exert the force on the ball during catching. Yes or no? Yes. It can change the shape of the object. If I have a plastic bottle, PET bottle in my hand, if I press, what happens if I press like this? It crushes, right? So crushing the bottle, then shape changes. If I have a rubber band, when I apply the force on the rubber band, it extends. So what happens? Shape changes. There is a glass. If we throw with a stone, right? What happens? The glass will break. So what is happening in this case? Shape changes. They are deforming due to the force exerted on them. Okay, and a net force can bring the direction, change in the direction. Okay, for example, this is a net. Okay, football game we are playing. Here we have I am the goalkeeper, right? So what is my duty? I have to change the direction of the ball. If the ball enter the net, opposite team people will get the point. Then what is my duty? I have to just change the direction of the ball. So when ball comes this way, I change the direction of the ball by applying force, right? So a net force can change the direction of the motion of the object. So these are all happen with the net force. But one thing you have to remember, this is very, very important thing. Net force never change the mass of the object. Mass of the object is constant. Mass of the object is fixed. Mass neither be created nor be destroyed. That is called law of conservation of mass. Okay, so you can tell me some examples. What you see in your daily life. What a net force. What are the effects of net force? Okay, so you can list out some other forces as examples after writing this. So please note down these important points regarding the effects of net force. After that, some of your daily life examples write on your own and refer these notes. Thank you children, have a nice day. Again we will meet in the next video. Okay, so we will discuss more about pressure and some important questions in this chapter. Okay, Thank you.